All right, welcome everyone to 7-6. This is the last couple lessons on our chapter 7. Today we're going to be looking at function operations. So we're going to look, as you see at the bottom, we're going to look at addition, subtraction, multiplication, and division, and looking at in function notation. So we're looking at the basic arithmetic with functions, and then we're going to move on into the idea of a composed function or composition of functions. So let's just take a quick minute to recall what function notation is. Looks like this little guy here that has an f with the x right there. This is f of x. What this is this tells me that this is a function whose name is f, and the variable in the function is an x. That's essentially what that is saying, and it's a way to differentiate between different functions when you're working on the same problem. So we could have f of x, we could have g of x, we could have h of x, and all that kind of idea. When we evaluate function notation or evaluating using function notation, this f parentheses 3, that means f of 3, and essentially what we are asking is what is the value of the function when we substitute 3 in place of x. So if we were to look at an example, let's call this f of x. Let's name a function f of x is equal to 3x minus 7. We now have a function 3x minus 7. This is function f. And if we were to try to find f of 3, we could find f of anything here. F of 3 says let's substitute 3 in place of x. So we get 3 times x, but in this case my x is a 3, minus 7. We get 9 minus 7, which is 2. That means f of 3 is equal to 2. So you always have to remember that this is f of 3, not f times 3, and this is f of x, not f times x. This is a notation that we use in every level of mathematics above Algebra 2. So with that out of the way, we can now look at function arithmetic. So we have all 4 of the basic arithmetic functions here, or ideas. And the first one that we're going to look at is, we're going to list them. So the first one here is summation. This is really the 2 different ways that this gets written. But essentially, you're going to say f plus g of x, which can mean take the function f and add it to the function g. Now what we'll notice is a lot of the problems that we'll be dealing with are polynomials. So essentially when we add or subtract, as you see, they're basically the same idea. We're just going to be combining like terms because that's how you add and subtract polynomials. In multiplication, again, this is how this is going to be written, f times g of x. That's the left one here, f times g of x can be rewritten as f of x times g of x. And likewise with the division, the only little issue here is that we cannot let g of x be 0 because we cannot divide by 0. So if we were to look at a few examples here, kind of stuff that you're going to see as we get going, if I was to call the function f of x, let's just call it 3x minus 7 because we already had that earlier. And let's get a new function called g of x, which is x squared plus 2x minus 1. All right, we can find f plus g of x. F plus g of x is just the sum of f of x. So we need to take f of x, and we need to add it to g of x. So we're using this first line saying f plus g of x. means take the first function f and add it to our second function g. And as we always do in this type of problem, we're going to combine our like terms. So we have nothing to add to the x squareds. We have 2x plus 3x, that makes a 5x. And we have a negative 7 plus negative 1, which makes a negative 8. And this we have f plus g of x. Sticking with this, we could say f minus g of x. We're going to do the same idea here. In this case, however, we're going to subtract. And you have to remember, when you subtract, that essentially means we're going to distribute this minus sign. All three pieces get the minus. So we get a negative x squared because now we're subtracting x squared. Then we get 3x minus a positive 2x, so we get a positive 1x. And we get negative 7 minus negative 1, which means plus 1, so it's negative 6. Now with multiplication, I've been using parentheses purposefully in multiplication. Oops, forgot to put parentheses around those other x's up there, didn't I? All right, with multiplication, you do have to remember parentheses because they are very important. When I have f times g of x, I'm going to take 3x minus 7, which was f of x, and I'm going to multiply it with the g of x function. And when we multiply, you just have to think a bunch of distribution pieces. So we're going to take 3x and we're going to multiply by everything. 3x times x squared gets 3x to the third. 3x times 2x gets me 6x squared. 3x times minus 1 is a minus 3x. And we just have to go now with the negative 7. So negative 7 times x squared is negative 7x squared. Negative 7 times plus 2x is a minus 14x. And negative 7 times negative 1 is a plus 7. And then, as always, you simplify, combining your like terms. So we get 6x squared minus 7x squared, which is minus x squared. Minus 3x minus 14x is minus 17x, and the plus 7 is by itself. And there we have the product of the two functions. All right, and with the division, for the most part, all we are going to do is we are going to write them as the division pieces. If we did f of x divided by g of x, we would get 3x minus 7 all over x squared plus 2x minus 1. And essentially that is it for what we are going to be doing. Now we do have to make that note that this denominator piece cannot be 0. All right, so that is the basic arithmetic functions. And what we're going to go to now is look at the composition of functions. Now, the composition of functions is going to be very new to us, but it's not going to be too far along for us. So, in composition of functions, what this is a way to combine two functions. And what we do is we input one function into the other. Just like we did when we evaluated the function at a certain number, like f of 3, we can put a different function. We can say f of g of x. Or in this particular case, I wrote it the other way, we could say g of f of x, which means we're going to be plugging in f of x into the g of x function. We get an all new function through what's called composition. This note is for what's going to be coming up in a little bit. We're going to be looking at evaluating. so plugging in a number to get out a different number. Evaluate a composition, so in our case, what I wrote here is something like g of f of 2. You're going to work from the inside out, so you need to figure out what is f of 2, and then you're going to use that value to plug in for x on the function g. And you'll see an example like that coming up. So, with our functions, let's name a couple functions here. Let's just look at a couple easy ones. Let's say f of x, we'll just keep using that 3x minus 7 for now. And let's look at g of x being 4, oops, let's not do that. Let's go with 2x plus 1. So first let's look at some evaluating pieces or examples. Let's look at g of f of 2, since that's the example that I pointed out. So we need to come over here and we need to figure out what is f of 2. So from one of the first things we learned today, f of 2 just means plug in 2 for x. So we're going to say 3 times 2 minus 7 is 6 minus 7, which is negative 1. So we found f of 2, and then we're going to replace that for this piece. We know f of 2 is negative 1, so this becomes g of negative 1. And then we actually have to do this piece. So g of negative 1 becomes 2 times negative 1 plus 1, negative 2 plus 1, which is negative 1. So that means g of f of 2 is equal to negative 1. Now, they will not always come out the same like this. This was just a lucky coincidence. So with that, let's try a little bit different of a problem here. Let's try, instead of a 2, let's try g of f of 5. So again, we need to work from the inside out. So we need to figure out f of 5. f of 5 means plug in 5 for x, so we get 3 times 5 minus 7, which is 15 minus 7, which is an 8. Then we're going to take that out 8 and replace it in g inside this function here. So this becomes g of 8, because f of 5 equals 8. And then we plug 8 into the g function. So we get 16 plus 1, which is 17. All right. This can work in either direction. We could also do things like f of g, f of g of 1, which means now we have to look at g being the inside function, so we need to do what is g of 1. So g of 1 is 3, so now we can say what is f of 3. And f of 3 is going to be 3 times 3 minus 7, which is 9 minus 7, which is 2. All right, so with that, we could also do something a little bit different. Rather than using a number, let's see what it means to actually do f of g of x, composing two functions, not looking for a numerical answer. So what g of f of x means, f of g of x says let's plug g in place of x. So for the function f, it's 3 times something minus 7. Now normally it's 3x minus 7, but in this case we're going to replace g of x for x. So g of x is 2x plus 1. And then it becomes a simplifying problem. So 3 times parentheses 2x plus 1 becomes 6x plus 3. And then minus 7, and we get a new function, which is 6x minus 4. And that would be the new function, the composed function f of g of x. But let's look to see what happens if we go in the opposite direction. What would be g of f of x? Well, this means I need to put f into g. So we're going to say it's 2 times something plus 1. And in this case, f is our something of 3x minus 7. Again, it now becomes simplifying, so it becomes 6x minus 14 plus 1, which is 6x minus 13 for g of f of x. So notice the composition gets two different answers when we went in the opposite directions. All right, so I think I have given plenty of examples. There is one minor example that I want to put that's not really part of the compositions, but it is something we do want to take care of. If we have the function f of x is equal to 3x minus 7, if I wanted to find 5 f of x, 5 f of x is really 5 times f of x. So that's going to be 5 times the whole function f of x, and we get a new function, 15x minus 35. All right, that was just a minor piece that I wanted to put in. Really didn't fit anywhere outside of just an extra little example. All right, I hope you learned enough stuff today. I'm going to give you guys the assignment in case you are wanting to get ahead. Here it is. I will see you guys later.